Chapter number 1: Cubes and cube roots of numbers. When a number is multiplied by itself 3 times, the product is called its cube. For example, 4 times 4 times 4 is equal to 64. We say that 64 is the cube of 4. The cube of a number n is given as n raised to power of 3. And so 2 cubed is equal to 8, 3 cubed is 27, and so on and so on. One method of obtaining the cube of a number is by direct multiplication. For instance, 12 cubed. We first multiply 12 times 12. So we have 4 and 2, and then 2, 1. And if we add that, we get 144. Then we multiply 144 times 12. If we do that, we get 4, 4 and 1. And then we have 8, another 8 and 2. We add that, we get 1728. But this multiplication is long, tedious, and time-consuming. In modern mathematics, we use mathematical tables. Mathematical tables of cubes of numbers look similar to those of squares, and we read the tables the same way we did with squares and square roots. For example, the cube of 3.353. 3.3 is here. We go to the column of 5, they coincide here, and the number is 37.595. Last decimal place, we go to the differences column, specifically to the column of 3. They coincide here, and the figure is 101. We add to our previous reading, and if we do that, we get 37.696. And so the cube of 3.353 is 37.696. Now, the tables of cubes of numbers give the cubes of numbers from 1.000 to 9.999. For numbers less than 1 and greater than 9.999, we first convert them into standard form. For example, 0.162 cubed. In standard form, that is 1.62 times 10 raised to power negative 1, and then everything cubed. The cube of 1.62, this is 1.6. The column of 2 coincides with this row here, and the number is 4.252. We do not have a third decimal place, and so we stop here. Cube of 10 raised to power negative 1 is 10 raised to power negative 3. And so our answer is 4.252 times 10 raised to power negative 3. You can leave it in this standard form or convert it to 0.004252. But I think the standard form looks more learned. Finally, the cube of 140.9. In standard form, that is 1.409 times 10 raised to power 2, and then everything cubed. First, the cube of 1.409. 1.4 is here, and next is 0. They coincide here, and the number is 2.744. We look for 9 in the differences column. They coincide here, and the figure is 56. So we add that. The cube of 10 raised to power 2 is 10 raised to power 6. Next, we move to cube roots of numbers. A cube root is simply that number you multiply by itself 3 times to get the cube. And so if 9 times 9 times 9 is 729, then the cube root of 729 is 9. This is represented like this. Numbers that have whole numbers as cube roots are perfect cubes, like 8, 27, 64, and so on. Most numbers, however, are not perfect cubes, but that does not mean they do not have cube roots. One method of finding cube roots is using factorization method. So we first express the numbers as a product of their prime factors. For instance, the cube root of 91,125. In its prime factors, this is equal to 3 times 3 times 3 times 3 times 3 times 5 times 5 times 5. This simplifies to 3 raised to power 6 times 5 raised to power 3. And then we find their cube roots. We will see in the next chapter that to find the cube root of an indexed number, we simply divide the power by 3. And so the cube root of 3 raised to power 6 times 5 raised to power 3 is 3 raised to power 2 times 5 raised to power 1, and that will give us 45. You can even find the cube root of fractions by simply finding the cube roots of the numerators and then the denominators separately. For example, the cube root of 4 and 17 over 27 is an improper fraction that is 125 over 27. Cube root of 125 is 5 and the cube root of 27 is 3, and so we have 5 over 3 as a mixed fraction that is 1 and 2 over 3. Now, working cube roots this way is tedious. Then again, not all numbers can be expressed in prime factors. So we use the tables of cube roots. This is a cube root table. Tables of cube roots give the cube roots of numbers from 1.000 to 999.999. At this level, we will only have tables between 1.000 and 9.999. We read the tables just like before. For example, the cube root of 4.731. We go to 4.7, move along that row up to where it coincides with the column of 3. The number here is 6786. Notice, however, that all numbers in that entire row begin with 1 point. So I put 1 point and the number is 1.6786. To the differences column, we go to column 1 and the figure is 1. So we add to it 1.6786, we add 1 and we shall get 1.6787. How about numbers greater than 999.999 and less than 1.000? In such cases, we write them first in standard form, but ensuring that the power of 10 is a multiple of 3. For instance, the cube root of 0.00169. In standard form, that will be 1.69 times 10 raised to power negative 3. Then everything under the cube root sign. Cube root of 1.69 is 1.1911. That of 10 raised to power negative 3 is 10 raised to power of negative 1. So we have 1.1911 times 10 raised to power negative 1, or simply 0.11911. Notice that while negative numbers have no square roots, they do have cube roots. Good luck with cubes and cube roots.
I love that math generally has initially clear and precise answers, that you know when you know it and you know when you don't know it. As you get farther on in it, the answers are not so clearly in the back of the book, but initially math has answers, clear answers. Sometimes they're hard to find, but that clarity. The second thing I love about math is it's a puzzle-solving kind of, if I can figure it out, and the joy of figuring it out, the kind of sense of accomplishment, the sense of excitement when you get it. the challenge of trying to get it. It's that puzzle solving kind of thing that I really, really like.